Hi Year 9, this is a continuation of exercise 1205. In this video, I'm going to look through questions 3 to 9. So in the following questions, give your answers correct to the nearest degree. So in questions 3 to 8, we have some worded problems with a diagram that we need to use in order to find the angle that it's asking for. So this says that a ladder reaches 9 meters up the wall and the foot of the ladder is 2 meters from the base of the wall. We're asked, what angle does the ladder make with the ground? So we're trying to find this angle here, and we have been given these side lengths. So let's draw this information into a triangle for us. So it will look like so. Okay, and we have our right angle here. We have that this is 9 meters. We have that this is 2 meters, and we have that this is our angle that we're trying to find. Now, in regards to our angle, we want to find label our triangle. So our hypotenuse is our side opposite our right angle. Our opposite side is opposite our angle. That's our opposite, and our adjacent side is next to our angle. We then want to use our tan ratios, which is tan theta equals O over A in order to find our angle. So then we substitute in our opposite side. So we know our opposite and our adjacent side. So our opposite side is, so we have tan theta equals our opposite side of 9 over our adjacent side of 2. We then write theta equals 10 to the power of -1 of 9 over 2. We then put this into our calculator. So a reminder of how to do this on your calculator. You press Shift 10, then you put in your fraction. So our fraction is 9 over 2. You hit equals, and then you hit your degree, minute, second button. So let's do that. So we'll go Shift 10, our fraction of 9 over 2 equals our degrees, minute, second button. And when we do that, we get our angle equals 77 degrees, 28 minutes, and 16.29 seconds. Now, we have been asked to round up to the nearest degree. So when we're asked to round to the nearest degree, we look at the minutes, and if our minutes are greater than or equal to 30, we round up. So 28 is less than 30, so that means that our angle of theta is just going to stay the same at 77 degrees. So question 4 is exactly the same process as question 3. So it says a road is inclined so that the rise 1 meter for each horizontal distance of 8 meters. What angle does the road make with the horizontal? So we have our diagram given to us, but in your books, it's a great idea to draw a triangle representing this diagram so that you can label nice and easy. So when we draw our diagram, we have that our angle is in here. We have that this is 8 meters and this is 11 meters. Once you've drawn your diagram, you follow the exact same processes that we did in question 3. Again, with question 5, it says a certain time of the day, a tree is 25 meters high, casts a shadow 32 meters long. At this time of day, what angle do the rays of the sun make with the ground? So again, we can draw a nice big triangle in our books in order to find the unknown angle. So we have that our unknown angle is here. We have our tree is here, which is 25 meters, and our shadow is 32 meters. So again, with question 5, you follow the exact same process as question 3. Now we have questions 6, 7, 8, 9 on our pages. So we're going to look at question 6. So question 6 says to find the base angle of an isosceles triangle if the height of the triangle is 15 centimeters and the length of the base is 22 centimeters, sorry. So what we're going to do is we're being asked to find this angle in here is what our question is asking us to do. Find the base angles. So remember, the base angles of an isosceles triangle are exactly the same. So that would be theta as well. We then have been given the information that this is 15 and that this is 22. So because an isosceles triangle has been cut exactly in half, that means that this length from here to here will be the same as the length from here to here. So it is split up in 2. So half of 22 is 11. So that means that this is 11 centimeters and this is 11 centimeters. Because our angles are the same in our base angles are the same, I'm just going to draw one of these triangles and we're going to find the angle for that. So we draw our triangle, we include our right angle, our height of our triangle is 15 centimeters, this base is 11 centimeters, which we worked out, and we're finding this angle here. You then follow the exact same processes for questions 3, 4, and 5 for question 6 now that you have the diagram. For question 7, it says, what angle does the diagonal of a rectangle make with each of the sides if its dimensions of the rectangle are 4.7 meters by 3.2 meters? So we want to find both of these angles here. So we want to find this angle in here, and we also want to find this angle in here. So what I'm going to do is, we know that with a rectangle, these sides are the same length and these sides are the same length. So I'm going to draw that top triangle on my page in my book so that I can draw all over it. Oh, that's not a very straight line, like so. Okay, so we've got our right angle in here. We have that this distance here is 4.7 meters. We have that this distance here is 3.2 meters. I'm now going to call this angle A and this angle B, and we're going to find the angle of both of these. So this one's a little bit trickier. So I want to find angle A first. So angle A is what we're going to find first. And so what we want to use is we want to use tan theta equals our O over A. So we need to label our triangle with respect to our angle. So we're talking about angle A, which is this angle here. So our hypotenuse is our side opposite our right angle, which is this one here. Now our hypotenuse is going to be the same for finding angle A and angle B, but angle A, the side opposite angle A, is 3.2 meters, and our adjacent side is our 4.7 meters. So we then just want to substitute these in. So we'll get tan theta equals our 3.2 over our 4.7. We then do the process of taking the tan to the other side in case you have forgotten 3.2 over 4.7. You put it in your calculator and then you're rounding it to the nearest. It doesn't say. You can choose what you want to round this one to. Then if we were to find angle B, I'll do angle B down here and I will make angle B, let's do green. So angle B is here. So again, with angle B, we have tan theta equals O over A. So with our diagram right now, our O and our A are not correct for angle B. So I'm going to erase my A and my O from my diagram. So my opposite side for angle B is the 4.7 and my adjacent side for angle B is my 3.2. So I would substitute those in to my formula. So my opposite side is 4.7 over my adjacent side of 3.2 and then solve to find the angle. For question 8, we're asked to find the angle of depression, so the angle marked theta in the diagram from the top of a cliff 50 meters high to a boat 800 meters from the base of the cliff. So this is a very small diagram, so I'm going to make it a lot bigger and make it easier to understand for you all. So I'm going to draw my triangle. So this is my 50 meter cliff. This is my 800 meters. My my boat is out to sea here, like so. And we want to actually find this this angle here. So we're asked to find this angle here. So what we should know from our angles from year 7 and the start of the year is that we have alternate angles here. So by alternate angles, what I mean is it makes a Z. So when we have alternate angles, you should remember that with alternate angles, that these two angles are the same. So now that we've worked that out, we can find out what this angle is by labeling our triangle. So we have our hypotenuse, which is this side. We have our opposite side from our angle, which is our 50, and our adjacent, which is next to our angle, which is our 800 meters. We then can substitute this into our tan theta equals O over A trigonometric ratio. So we'll have tan theta equals 50, because that's our opposite side, over our adjacent side of 800, and then we can solve for theta, just like every other question. Finally, question 9, it says trigonometry can be used in number plane work to find angles. We're going to use the colored triangle to find the value of theta to the nearest degree in each of the following. Now, you are to work out B and A, so I am going to do C for you today, just so that you know how to do it. So with C, we have a triangle, and we want to work out what the distances of our triangle are. So I want to work out what my distances are. So I want to work out what this distance, oh, that's too thick, what this distance here is and what this distance here is. So if I look at my my graph here, this is the 0.5 and this is the 0.2. So the 0.1 is here. So the distance between 1 and 2 is obviously 1. And the distance between a half and 1 is a half. So that means that this distance here is going to be 1.5 or 1.5, however you want to write it. Then to work out this distance here, it goes from 2 up to 1. So that means that the distance from the x-axis to that point is 1. I'm now going to draw that triangle down below and put on the information. So we have that this is theta, we have that this is 1 and this is 1.5, and this is a right angle where the vertical and the horizontal lines meet. What we want to do now is exactly the same as we've done for every other question. Is this is our angle, we then just want to label our triangle. So this is our hypotenuse is opposite our right angle, our opposite side is opposite our angle, and our adjacent side is next to our angle. So we then just want to use this and our tan ratio, so tan theta equals our O over A, and substitute that in.